Alright, so hopefully you're having a good evening so far, and hopefully the handout in front of you says metric system because that's what we're going to be talking about today. What do Liberia, Myanmar, and the United States have in common? Maybe you know this, maybe not. They are the only countries that do not completely use the metric system. So they use other systems like our customary system with inches and feet and yards and things like that, also pounds. So that is something unique that the United States does along with some other countries. But it's probably because we are super stubborn and don't want to be like the rest of the world, so we made up our own system that nobody else really cares about. So for science purposes, we are actually going to be using the metric system. And you ask, why are we using the metric system? It is because it is precise and accurate. So there's none of these half inches, quarter inches, things like that, because really we don't have anything that's smaller than an inch in the customary system, which is a little weird. And it's also reliable and standardized. It's actually in base 10, so it's not like 12 inches equal 1 foot. It would actually be nice and neat in tens and hundreds and thousands and things like that. And it's also understood by a whole entire audience. So if you were to publish your data or your findings in an experiment, everybody would know what you were talking about because you're not using this customary system that only our country uses. You're actually using the metric system, which is more widely known as far as the world goes. So the metric system is required in this class, so it is imperative that you know exactly what we're talking about. So again, why are we using the metric system? It's because most of the world and scientists use this standardized system. Metric is based on units of 10, so again, the kilo is 1,000, hecto is 100, deca is 10, and then you also have your base units in the middle, and then deci, centi, and milli. So of course, I hope you've heard of all of those before. Maybe not hecto, deca, and deci, but definitely centimeters, millimeters, actual meters, liters, stuff like that. Alright, so here is a handy dandy chart for you. So you probably need to be looking at this kind of stuff on your, let's see if I can do my arrow. Maybe not. Okay, whatever, Misty Duck, we're just going to go with the flow. Okay. Alright, so the kilometer is all the way at the top, and if you can see up here, 1 kilometer equals 1,000 meters. 1 decimeter equals 0.1 of a meter, so they're actually not going in order. But this is all used for length. For volume, you use liters. For mass, you use grams. And then for temperature, you can use kelvins or Celsius. For the most part, we're going to be using Celsius in this class. So for length, the base unit is a meter. So you need to know that. Centimeter is your width of a pinky. So if you look at your pinky finger, most likely that is 1 centimeter. We're going to be using kilometers and also millimeters and things like that. Some instruments that you can use are tape measures, rulers, meters, and things like that. So if you can look at this, how long is the shell in centimeters or millimeters? Well, in centimeters, you would start at 0. Always make sure that whatever you're measuring starts at 0. You don't want to start measuring from the 1 or the 2 or the 3 or anything like that. So it looks like it is at least 1 centimeter. Whoops. It's more than 2. It's more than 3. It's more than 4. It's actually 4.5 centimeters. But you need to tell me on your paper how many millimeters that might be. So hopefully you don't go back counting. Maybe you can figure out how many millimeters there are based on the fact that it's 4.5 centimeters. Alright, for volume, this is the amount of space that an object takes up. So we're going to be using graduated cylinders for this. This is for liquid volume, and your base unit is a liter, so maybe you've heard of that before. And again, the instrument that we use is a graduated cylinder, and you would always measure from the bottom of the meniscus. Now the meniscus is kind of like this circular thing down here, and if you look at it from eye level, it actually kind of dips down a little bit, so it makes like a curve. So you'll never measure from the top of it, you'll always measure from the bottom of it. Okay, so maybe you can see what the graduated cylinder has. But before we do that, let's answer this question down here. Which has more volume, 2 liters of Pepsi or 2 liters of air? Well, they're both 2 liters, so they actually are the same, okay? And how much liquid is in the graduated cylinder? Well, you would look right here. Look at the bottom of your meniscus right here. Okay, and it looks like this is the 60 mark, this big mark right here. Since this big mark right here is 50, we're going to go up 10 more, and we still have more liquid in there, so we're going to count up 1, 2. So it looks to be 62, and I think these are milliliters on our graduated cylinder. Now the next one is mass, and that's the amount of matter in an object. And we use grams, which is approximately just 1 paperclip. So if you put a paperclip on a triple beam balance, it will give you 1 gram. A family car, so if you look at your car in your family, it's about 1,000 kilograms, so that's a lot of paper clips. And your instrument that you'll use is a balance, and make sure that you always zero it out before you use it. We'll do that in class a little later on, so that way you can see how to work that. The cool thing about mass is that it does not change with gravity, so your mass will still be the same even if you go to the moon. Your weight is the measure of gravitational attraction. You can be weightless, and you can weigh less on the moon. So you have the same mass, but your gravitational attraction is different there, so your weight is different. So if anybody tells you, will you mass change when you go, out in space and things like that? No, your mass will not change, but your weight will. Your metric unit is a Newton, which is an apple, which is funny if you actually know who Isaac Newton is and his story about the apple, which is kind of funny. And the instrument that we use is a spring scale. We won't be using this a lot in science class, but it's good to know. And your weight is your mass times 9.8 for Earth, because this 9.8 represents the gravitational pull that the Earth has on you. Alright, so what's the difference between mass versus weight? You can read that at your leisure time. Basically, weight is the measure of an object with gravity kind of factored in there, and mass is just the amount of stuff inside of something. Temperature, we always use Celsius in class, so don't ever tell me that something is 70 degrees Fahrenheit, because I don't know what that means in science class. We always use Celsius. 100 degrees Celsius is a boiling point of water, and 0 degrees is freezing, so that's a lot easier than Fahrenheit, where it's 32 degrees Fahrenheit for freezing and 212 for boiling. So those are kind of odd numbers, so we're just going to stick with Celsius. Room temperature is about 20 to 25 degrees Celsius. We always use a thermometer when we're measuring Celsius. And sometimes scientists like to use Kelvin, but we're just going to stick with Celsius. Alrighty, so this is exactly what you need to know. For mass, we use a beam balance or a triple beam balance, and that measures grams. Weight, we use a spring scale in newtons. Temperature, we use a thermometer, and that is in degrees Celsius. Length, we use most likely a ruler, and we use centimeters, so you could just put meters down if you want to. For liquid volume, we use a graduated cylinder in liters. And for solid volume, we also use a graduated cylinder if it's irregular. Alright, so density. You can always look at this little thing up here if you really want to, and it'll kind of give you a description of density if you want. But it is just mass divided by volume, and we're going to be going into this all year long, so don't worry about it if you don't understand it or don't know why it is mass divided by volume. But we'll be doing a lot of that. You'll also be doing that a lot in math class too, so make sure that you have that down. Your units for your answers will always be in grams per milliliter because it's mass by volume, or grams per centimeter, which you probably won't do. The important thing is that if your density is greater than 1, your object will sink, but if it's less than 1, the object will float. So that's very important to know. So for example, 2.7 grams would do what in the water? Obviously, it will sink because it's greater than 1. You will use a balance for this and a graduated cylinder to figure out the mass and the volume, and of course a calculator to divide those. So some other examples. Gold has a density of 19.3, so that will sink. Lead has a density of 11.3, so it'll also sink. Aluminum is 2.7, so it will also sink. Seawater is 1.025, so it has a greater density than fresh water, so it'll actually sink because it's salty, and the saltier it is, the more it will sink. You'll learn about that with currents and hydrology later on in the year. Pure water is exactly 1.0 because it's actually the water that you're testing in. Ice is 0.92, so that will sink. Gasoline is 0.7, or I'm sorry, ice will actually float, and gasoline will float. Oak will actually float, and oxygen floats as well. So you can't really mix oxygen and have oxygen at the bottom of your glass of water because it's going to float. And you can always try these at home if you have a piece of gold, maybe, or something like that. And the last one is helium, and this one will float as well. When you're converting, you'll learn a lot about this in math class, but always remember King Henry died by drinking chocolate milk. So that means that you can move the decimal over to the left or move it over to the right depending on what you're doing. We'll do a lot of this in class. You don't need to worry about it right now. You can do these if you want to by making your little graph, but you don't need to do it right now if you don't want to. Same thing with these. We don't need to do these right now either, but you can try them if you would like. If you want to measure the length and width of your classroom, which unit would you use? So if you're measuring with length, you would actually use meters. Which unit would you use to measure the amount of matter in your book? Well, amount of matter is mass, so you'd be using grams. Which would you use to measure how much water a drinking glass holds? So that would be volume, so you have to be thinking about liters for that one. And what would you use the Celsius scale for? So that's temperature with the thermometer. And was the smallest unit of the metric ruler? That would be millimeters. How many millimeters are there in 1 centimeter? Well, that is actually 10 if you look at your King Henry died by drinking chocolate milk scale. And then you can figure out that bottom one if you would like. You don't need to worry about these either. And here is a challenge. 25 milliliters equals how many cubic centimeters? We haven't really talked about cubic centimeters, but if you want to figure it out, you can. Or you can figure out that 1 milliliter equals 1 cubic centimeter. So it would actually equal the same. Alright. You can look at this at your leisure time. You can end this video right now if you really want to. I'm just going to go through the rest of this. If you want to learn about scientific notation, you'll learn about this later on in math class this year. But it's basically just moving the decimal point over, multiplying it by 10 and an exponent. So for this one, you had to move the decimal place over 9 spots. Okay, so if you start here at the back, you would move it 1, 2, 3, 4, 5, 6, 7, 8, 9 spots to get it because you always want it to land right after your first digit. Okay, so it'd be 1.39 times 10 to the 9th power. Okay, so again, you'll learn more about that in math class, so don't worry about it right now. Alright, we're going to be using graduated cylinders later in class, so you don't need to worry about that. And also meter sticks and triple beam balances.